Hi, I'm Larry Puckett, the DCC guy. Today we're going to be taking a look at a couple of new gadgets that I've got for you to use on your model railroad. One of them is a lighting product, and the other is an auto reverser circuit that you can use on reverse loops and on Ys, things like that. So let's take a look at those. Hit that little red subscribe button, and when the little bell comes up, click on it and click all. Now before we get started, there's something that I want to share with you. For the next 4 weeks through the middle of August, I'm going to be tied up with some personal matters. And I don't know how much time that is going to give me to keep to my schedule for producing videos. So for the next month, the videos may occasionally be late, or there might not even be a video 1 week or another. So it's just going to depend on how much free time I have in order to do this for you. So if a new video doesn't pop up, take that week to go back and take a look at some of the older ones that you haven't seen or that you might need to take another look at just to refresh yourself on something. Now, first off, from DCC Concepts, I have these lighting control circuit boards. Now, these are designed to be used with their legacy lighting light products like these here that I showed you how to use and install on your model railroad a few videos ago, and the various other lighting products. These are a similar set of lights, but these, instead of having LEDs, actually have small, very small incandescent bulbs in them. But the lighting circuit board that I'm going to be showing you here is made to be used both with LEDs and with your incandescent bulbs. So that's something that gives you a dual use product. And the interesting thing about it, it can be used with DC, DCC, or AC power at 6 to 24 volts. So right here you can see I've attached a couple of clip leads from a 12 volt DC power supply that feed in here on the board. There's a couple of pads right here, and I'll zoom in on this here in a minute. But anyway, so you've got power coming in here, you've got a bridge rectifier right here, and that converts any AC power to DC, and then you've got a number of different electronic components to give you a good stable voltage out to drive your LEDs and your very small light bulbs. And these light bulbs are probably somewhere down around 2 to 3 volts, something in that range. If we look at the board, it also has a little device here on it called a trim pot or a potentiometer, and it has a little brass screw. And I'll show you how that works in a minute. But basically, that is there in order to allow you to adjust the brightness. Now these come in a single pack or a triple pack, and you can get these from DCC Concepts in the UK. Rails of Sheffield is one of their primary dealers over there as far as the hobby shops go. Here in the US, Iron Planet Hobbies is a potential source for these as well. So you can use these in place of those small resistor boards that I showed you that come with these lighting products from DCC Concepts. But you can use them with even some of the lighting products from companies that make similar types of LED type driven circuits, and that would include the Woodland Scenics Just Plug lights. And like a lot of the products from DCC Concepts, these little circuit boards come with mounting screws and 4 holes in the circuit board. So you can screw them to the underside of your layout, wherever you want to get them out of the way in your installation. Okay, I've zoomed in here to give you a closer look at this little lighting circuit board. Now, the interesting thing about this, they do not provide a screw terminal type of situation here. There are these small solder pads provided here on the circuit board. So you can solder your power supply connection here, or I've just used clip leads in this case for a temporary test setup. On this other side, they have 2 of those solder pads where you can connect leads to an incandescent light bulb. And even though they mark them as plus and minus, it really doesn't matter because an incandescent bulb is going to burn no matter which way you hook it up. What is important though here is the LED side, and it's marked clearly as LED plus and LED minus, and on this particular one it has a red and a black lead, so red is positive, black is negative. On these various LED lights, they did provide these with a longer lead, it's about 2 inches longer, on the positive wire. So that allows you to keep the polarity correct for these. So all I've done here then is simply taken both of those wires and soldered them to that plus and minus solder pad for the LEDs. In the instructions, they say that you can use up to 12 of these LED products and 6 of the incandescent bulb products. And they have tested them at that amount. Assuming that each one of the LEDs here, these high intensity, high efficiency LEDs that they use, are rated at about 10 milliamps each, and they say you can fire up 12 of them, then I'm assuming that this is rated at about 120 milliamps on the output. Probably 150, but they've only tested it with 12 of them. Now, I've already asked them if they can provide me with a actual amperage rating for the output on this circuit board. So I'm hoping that they'll get back to me with that. Other than that, if you're going to be using these with products other than the DCC Concepts bulbs, you pretty much have to assume then that you can only use about 10 or 12 LEDs with it and 6 bulbs. I'm assuming that these small bulbs right here are probably only drawing about 20 milliamps. So that's not a whole lot. One of the problems that's cropped up in the last few years for folks like us that use LEDs is that the older LEDs, the larger individual ones with the big legs and all, they're rated typically at 20 milliamps. These higher efficiency LEDs that are used in products like this one here, and this one here, and the Woodland Scenics ones, they probably are coming in more at about 10 milliamps. And some of the super high efficiency LEDs that you can get in surface mount fixtures are probably coming out in the single digit values, down around 5 or so. So it's really hard to know unless you've got a spec sheet on the LED when you buy it, exactly what it is pulling. So you have to be conservative in this and stick with their value of 12 and 6 for the small incandescent bulbs. Okay, so as I've said, I've already hooked up one of these incandescent bulb fixtures to the output here, and I've hooked up these 2 LEDs. So this is that legacy lighting LED I showed you how to install a few videos ago. And this is a small surface mount LED light that DCC Concepts sells. It has adhesive on the back to stick to surfaces inside of a building site. And I used these when I was lighting my gas works on my module. So you could go back and take a look at that if you're interested in how these work. And I also, by the way, used just plug lights with that circuit that I used to control these. So, you know, you can easily mix just plug lights with these as well as those made by various other manufacturers. Okay, so I've already hooked this up. Let's give it a test and see if it's going to light up. Okay, so there we go. You can see we've got this LED bright, we've got this one, and the little incandescent bulb here is just barely glowing. So what I'm going to do is, I'm going to take, and right here is a little adjustment screw. It's a little brass adjustment screw here on this potentiometer. So this is called a trim pot. And what you can do is just take your screwdriver and get it in that little slot. There. And I'm going to give that a turn. And turning it to the right decreases the brightness of your LEDs. You can see those dimming. Now I'm going to start turning it back up to the left, counterclockwise. And you can see the brightness of the LEDs in particular has gone up considerably. This little guy doesn't change very much at all, much more stable than our LEDs here. So that's very simple and easy. All you have to do to install these to hook up your lights to it is just wrap the LED leads together and solder them to the pad. Same thing for a light bulb. You would just solder the leads to the pad here and then hook up a power supply rated at anywhere from 6 to 25 volts AC, DC, or DCC. And that will allow you to light your various lighting products in your buildings and your street lights, anything that has one of these LED or a light bulb in it. So these are an interesting little product, much easier to use than those little resistor boards that come with these legacy lighting products. You'll actually be able to make brightness adjustments directly instead of soldering and unsoldering and finding out which resistor combination gives you the brightness you want to use. Okay, so that's enough about this one. Again, these are available from DCC Concepts in the UK and their various dealers there and around the world. Here in the US, that is Iron Planet Hobbies is a good choice to contact to see if they have these in stock. Next product that I have for you is the PSXX-AR. Now this is an automatic reversing circuit designed to work with the PSXX circuit breakers from DCC Specialties. In previous videos, I have shown you the PSXX circuit board and talked about how it operates. So in this one, we'll take a look at the PSXX-AR. And I will put a link to those videos above me here, and you can go back and look at any of those that you want to take some time to. So let's go ahead, and I want to introduce you to this board. It is somewhat different from the older PSXX-AR, which was the earlier version of this auto-reversing circuit board. Let's go ahead and begin with this schematic here. And this schematic is from the instruction sheet. So if you want more information that I'm going to be able to provide in this video about these, I suggest that you go to the Tony'sTrains.com website and do a search for the PSXX-AR. And that will take you to the product page. And they have a link there where you can download a PDF version of the manual, and it goes into a lot of the details. There's just so much in this that I can't cover it all today in this video. But let's go ahead and take a look. There's two different versions of this, the PSXX-AR, and as on the right, the ARC. Now the difference is the ARC is made to work with snap coil, and that's what the SC means, snap coil type switch machines. And that includes ones like the Kato and the Pico or Atlas switch machine. The one on the left, though, the PSXX-AR, works with tortoise switch machines and similar stall motor type switch machines. So as you can see, the board can control two different switch machines. So that gives you a lot of abilities on your model railroad to control reverse loops, staging yards, Ys, anything like that where you need to be able to control a turnout. Okay, let's begin here with the DCC booster, and we'll move counterclockwise around this circuit board. So you can see the input wires from the DCC booster go directly into jumper 1 here, and those are those red and black wires, and that gives you the power for the circuit board. So that would be what would normally go to your DCC power bus. It's going to run through this circuit board. And you can see right next to it, there's D12, a green LED, and that lights up when you've got power being supplied to the board by the booster. Also, right next to that one at jumper 10, they have solder pads where you can connect an LED for a remote installation. So you could put an LED on your control panel somewhere that would light up to let you know that the circuit board was powered. Okay, then we have jumpers 12 and 13, and those are for making connections to either your snap coil switch machines or to your tortoise type switch machines. And remember, the circuit board, the ARSC, only works with these snap coils. The AR will only work with these tortoise type switch machines. So be aware of that difference. Then next, going on around, we have the jumper 6, the trip level terminal. And that terminal there is a spot where you can solder individual jumper wires to create different trip currents. And I don't recommend doing this because it means you've got to solder to your circuit board. It's just a lot easier to use CV49 to actually program in a trip current. And for that, all you do is set it up for programming, go to CV49, and you can enter a value from 1 through 10 to give you from 1 through 10 amps for the trip current. Makes it very, very easy. Okay, coming on down here, we want to go down to jumper 7. And you can see that's for the optional manual reset switch. Now the way that these circuit breakers, and just about all of them work, when a short circuit occurs on the protected portion of your track, then the circuit will shut off power to the track. And at that point, it will wait a few seconds or milliseconds, however long it is set for the various device, and then it will try to reestablish power. If the short is still there, it will kick out again, and it will keep doing that over and over and over again. And in the meantime, you're going to have these transient shorts hitting your decoders on your layout in that section where the current has been tripped. Consequently, what I suggest using is the manual reset switch. And if you set this up to work, then when this short circuit occurs, power goes off and it stays off until you clear the short and hit this reset switch. So it allows you to do that, and you don't have these transient shorts on your protected section of your layout. Okay, and then note to the right of that, there's a red and a blue LED on the board. The red LED comes on when there's a short circuit. They also, as you can see, have provisions for remote LEDs, so you can have these LEDs also on a control panel somewhere that will show you when each of these conditions has occurred. Now also in here you can see there's JP1, and that is your operation and programming jumper. So you would move that jumper to one position when you want to program any of the CVs on the circuit board. So moving on down from there, you can see jumper 4 here is provisions for an optional manual off switch. So you can put that out on your control panel, and you'll be able to hit that button and turn power off whenever you want. You can also control power using throttle commands. Okay, down here on the bottom, you can see we have D11 and D20. And those are two green LEDs that show you whether or not the power to the track is set for normal direction of travel or reverse direction of travel. So it really gives you an indicator of what the polarity of the output wires to the track are set at. And every time that the circuit board reverses the polarity or phase of power, one of those is going to come on and the other will go off. So again, you can have these LEDs remotely mounted on a control panel somewhere, so you know exactly which way things are going to be going through your reverse loop. And then, of course, we have jumper 2 here with wires that go out to your track. Now, I'll talk more about that in a minute. Okay, the next one I want to show you here, this is the diagram or schematic for wiring up your PSXX using a daisy chain. So normally, you would have your PSXXs lined up here, your booster providing power to them, and then as you can see on the left, they're just daisy chained, out and back in, down at the bottom. And then they provide power out to various zones on your model railroad that they are going to be protecting. Now, when it comes to the reversing zone on the right, and they show it with two PSXX-ARs set up. Now, you'll note here that instead of just daisy chaining power from the booster to the inputs on the PSXX-AR, they recommend taking power from one of the PSX's output and feeding that into the PSXX-ARs. Now, there's a reason why they want to do that, and I'll go over that in just a second. But basically, what it comes down to is there are various levels of protection provided by a PSXX that are not built into the PSXX-AR. Larry Meyer told me the other day that if he had included everything in the PSXX-AR that is on the PSXX, nobody could have afforded these things. So what he did was he built it so that you can get that same level of protection as the PSXX provides by simply daisy chaining the output to the AR. That way, if something arises in the reverse loop that cannot be protected by the PSXX-AR, it will go back through these wires and default back to the PSXX. So it's a way of basically using one circuit to protect another one. So let's say we have a reverse loop like this one here with two PSXXs controlling the main line and then the AR providing power for and protection for the reverse loop here. So you can see he's got output going from the PSXX number 1 to the track, but also going out and feeding into the auto-reversing module. So it's going to be powering this, and it's going to be providing protection that is not built into the AR. Now, another thing that you have to be aware of is because of the way this is set up, if you get a short circuit here, it could potentially shut down the PSXX if you have these set at identical trip currents. So if both of these are set at 2 amps, then maybe half of the time this one would shut down and half the time that one would shut down. So what he did was, within CV49 on the PSXX-AR, when you set it for a trip current of 2 amps, which is the default value, it only sets it for a trip current of 1.8 amps. When if you have a short circuit or an overcurrent situation within the reverse loop, then and it goes over 2 amps, then the PSXX-AR will shut down first because it is set for 1.8 amps. So that's the way that you don't get these shorts going right on through to the PSXX and shutting it down as well. Okay, now there's one other thing that I want to point out about this, because there was a mistake made in earlier versions of the manual that only became apparent recently. Now this is the manual that I had originally. Version D of the software was the version I had. Now if you look at the input and output wire connections for jumper 1, you'll see we have a black wire over a red wire. On the output across from it, on jumper 2, output black over red. That's incorrect. Should look like this. Should be black over red for the input, red over black for the output. So this was a mistake in the original manual. This manual is the current one, version G of the firmware or software. So be aware of that. Make sure that you always maintain the proper polarity on these outputs to your track. Don't mix these things. If you've got 2 or 3 of these PSXXs, make sure that you've always got the red wire going to the right rail, the black wire going to the left rail, or whatever you want to use. Just make sure that you're consistent, because otherwise, anytime you cross a block gap to a miswired section, it's going to short out and shut down. So, one thing I recommend is always, whenever you are making any connections and wiring within a block or within on the layout, always test it immediately afterwards, because 95 to 99% of the time when people contact me with problems they're having on their layout, it turns out to be that they've wired something incorrectly, and it's usually they've ended up getting the red and the black wires crossed. Now, another thing, if we go back here to the reverse loop schematic. Now, one thing that Larry always points out in his instructions when he's talking about creating these isolated blocks here for the reverse zone or for the main line is always offset these gaps from one another by about 3/4 of an inch. And the reason he recommends doing that is you do not want both wheels on your lead truck hitting those gaps at the identical same time. It can cause problems. So pay heed to that. I pressed him on it. He said, yeah, you could probably get down to a 1/2 inch without any issues. So what do you do if you've already pre-cut and they're perfectly aligned with one another? Well, what you can do is go either side of one gap, cut another gap, and then push the small section of rail one way or the other so that it makes contact. And then you'll have a larger gap in there. Fill that with a piece of styrene and carve it to the proper geometry for your track. And if it's in an area where you can see it, go ahead, paint it to match the rails, and you'll never know it's there. So that's the easiest way I can think of to fix it if you've already pre-cut your gaps and they are perfectly aligned. So as I suggested, take some time, download the manual, and look at all of the stuff that is potentially available for you in this device, because it has so many features that I just can't possibly begin to go over each and every one of them. And you can add things. You can do block detection. You can have blocks programmed so that when a train enters a section or a detected section, it shuts off power. That you could use, for example, on a staging yard track. You could have an optical detector at the end of the track, and when it is covered by the locomotive, then it kills power to that track. And there's just a lot of other features like this that are available and provided for in this device. So take a look at that manual and don't get overwhelmed by it, because there's a lot of things in there that you probably will never use. But there's a lot of things in there that can be very useful if you do decide to use them. Well, that's a wrap for today's video. Take a look at the new PSXX-AR that you can use to automate your reverse loops and your Ys, things like that. Then take a look at this little lighting product here that you can use to power lights on your model railroad, including both LEDs and microbulbs. So, have a great week, have a great weekend, and I'll see you here next week, hopefully, with another video from the DCC Guide. Bye now.